Lesson 12.3a, analyzing geometric sequences. If you'll remember in the last section, we analyzed arithmetic sequences, and that was when we added over and over and over again. Geometric sequences have to do with multiplying over and over and over again. So a geometric sequence is when the ratio of any term to the previous term is constant. So if I've multiplied by something over and over again, and that common ratio is going to be our r. So the first thing you're going to need to do is determine, is this a geometric sequence? And the way you'll do that is to determine, is there a common ratio? So you'll look to see the common ratio between the first two would be your 10 over 4. And so reduce that down to 5 over 2. And then 18 to 10, and that's going to be, half of that is 9 over 5. And you could go on, but guess what? Once you find a couple that aren't, it might be a good idea to do one more just to see if, well, maybe I did something wrong and maybe I need to go back and check. Let's see, 14 to 9. No, this one is not geometric because it doesn't have a no common ratio. All right, and so I think your problem asks to describe why, and the reason is just there's not a common ratio. All right, so let's look here. 125 over 625, reduce that down, and 1 over 5. So 25 over 125, 125 will go into, A25 will go into, we'll go into 125 5 times. 5 over 25 equals 1 over 5 and 1/5. Yes. So this one is geometric, and it's because there is a common ratio. And the common ratio is 1 over 5. Ooh, over 5, not over S. All right? So the reason is the common ratio is 1/5. All right, so once you've determined, yes, this is a geometric sequence, then you're going to need to determine the rule. And I have a handy-dandy formula for the rule. The rule, if you've got a geometric sequence, is A sub n is the first term times your common ratio to the n minus 1 power. All right, and n, remember, is the number in the sequence. All right, so it's kind of sideways, so you can see that. So the rule, so in order to find the rule, you simply need to know, two parts, right? Two parts of these three. You need to know the first term, you need to know the common ratio to get the rule is the first term and the common ratio. All right, and that's what we need. So here, I've got the first term, and to find the ratio, we would just compare. So 20 over 4 is going to be 5. 5 over 1 is just 5. And then check the others just to be sure. 100 over 20 is also 5. 500 over 100 is 5. So the common ratio, so the ratio is 5. So the rule is put in, so A sub n is going to equal the first term, which is 4, times the ratio, which is 5, and am I in your way? Who knows? To the n minus 1 power. And that's the rule for this geometric sequence. All right. Once you get that, then you can figure like a to the 7th would be, a to the 7th is going to equal 4 times 5 to the 7 minus 1 power. 7 minus 1 is 6. 5 to the 6th power. I hope I wrote that down somewhere on my notes over there. Let's see. Oh, bummer. Oh man, I'll have to figure it out. Oh, guess what? I didn't figure 5 to the 6th, but I just figured the whole thing. A to the 7th is 62,500. Check my work to be sure. Take 5 to the 6th power and take that answer times 4. You should get 60,500. All right, let's move on. Let's do a different color just because I'm getting bored with blue. All right. Let's see. We've got a same type of thing. I want to find the rule. And then I want to find the 7th term. All right, so we've got negative 76 over 152. 66 or 12, 70. Oh, this is negative 1/2. 38 over negative 76. That's also going to be negative. 8 or 16. That's also negative 1/2. Negative 19 over 38 is also going to be negative 9 over 8, negative 1/2. So our ratio is negative 1/2. So we're going to plug in our first term in our ratio into our rule. So our rule is a sub n is going to equal the first term, which is 152, times the common ratio, which is negative 1/2, raised to the n minus 1 power. There's your rule. You're done with that part. Then to find a to the 7th, or the 7th term, not a to the 7th, a sub 7, the 7th term, you're going to take the 152 times negative 1/2 to the 7 minus 1, or the 6th power, to, let's see, negative 1/2 to the 6th power, it's even, so it's going to be positive. 2 to the 6th power is 64, so I have 152 over 64, which will reduce by 8, 1, 8, 9, 10, 11, 12, 13, 14, 15, 72 is 9. It does reduce by 8. 19 over 8 is the value of your 7th term. All right? Okay, easy sneezy, one more type. So now, if I give you the 5th term and the common ratio, now can you find the rule? Well, same type of thing we did with the arithmetic sequences. I really need to look up how to pronounce that, huh? All right. So we know that we don't have the rule, so we don't have a to the n, but we can put in a to the 5th as our n. We don't have the first term, but we do have the n, and we have the ratio, so we can figure out the first term. So let's put in a to the 5th is going to be 54, and that's going to equal, we don't know a sub 1. I keep saying to that power, that's not true. The ratio is 3, and the power is n minus 1. Well, we used the 5th term, so it's 5 minus 1, which is 4. So now we can figure out what the first term is. So 54 is going to equal a sub 1. 3 to the 4th is 3 times 3 is 81. So just divide by 81. So now 54 over 81, we can divide by 9 and get 6 over 9, and 3 and get 2/3. So your first term is 2/3. So your rule now is a sub n is going to equal the first term, which is 2/3, times the ratio, which we know is 3. Are you seeing where I'm getting these? I'm moving really fast. And then you're going to keep the n minus 1 power. So the first step was to find the rule, and then I want you to go ahead and graph these. They don't have to be exact, and so don't get all crazy. And they're going to be, because they grow exponentially. So you're going to need to have your graph set up so that your y direction is not just by ones. So you might have to go by 25s, you might have to go by thousands, depending on what your 6th term is. So what you're going to do is this. You're going to figure out, well, what are the first 6 terms, and then you're going to plot each one. So we already found our first term. We already found our first term is 2/3. So the second term is going to be 2 minus 1 is 1. 3 to the 1 power is just 3. 2/3 times 3, the 3's cancel, and so we just get 2. All right. Third term is going to be, so now we've got 3 minus 2 is 2. We're going to square it. So 3 squared is 9. So 2/3 times 9, well, we can reduce this and just say 2 times 3 is 6. All right, have you done 3 of them ahead of me now? So a to the 4th is going to be 2/3 times 3 to the 3 to the 4th power. 4 minus 1 is 3 power. So we know, and actually here's a little trick. We know that we can actually reduce this by 1/3 and just make that squared. So 3 squared is 9, 9, 9 are 18. And I'm going to need my eraser because I'm not going to have enough room. I don't know how far down you can see. All right, so now the fifth, oh, actually the fifth term we already figured out, or we were given, is 54. The sixth term then is going to be 2 over 3 times 3 to the 6 minus 1 is 5, but what we can do is reduce that and make that to the fourth power. 3 to the fourth power is 81. 81 times 2 is 162. All right, and now we're just going to plot those 6 points, and we're going to see the first term is 2/3, so the first term is really way down there. The second term is 2. Well, if my y value is 25, 2 is still like really, really low. And even 6 is only like a fifth of the way up. 18 is a little bit closer to 25. 54 is above 50 finally, so right about here, and then it jumps to 162. There we go. So you're going to see that these geometric sequences you're going to see are not a straight line. Remember with I told you, I didn't make you graph them. With the arithmetic sequences, they were a straight line. These are not going to be a straight line, all right? I think that's all we've got for today. We'll do some more tomorrow. So geometric sequence, they have a common ratio. Once you find that common ratio, you can put the first term and the common ratio in to come up with the rule. If you have a term that is not the first term, you can find the first term and plug it into the rule. All right, don't forget to graph. I'll see you next time.